All right, let's look at our last example here. It's going to be a business example. Surprise, surprise. Suppose that for a company manufacturing flash drives, the cost, revenue, and profit equations are given by C equals 5,000 plus 2x, R is equal to 10x minus 0.001x squared, and profit is equal to revenue minus cost, of course, where the production in 1 week is X flash drives. So in this case, the problem's already telling me X represents the number of flash drives. If production is increasing at a rate of 500 flash drives per week, when production is currently 2,000 flash drives, I want to find the rate of increase in profit. So before I go and solve this problem, I would recommend that you try as much of this problem as you can by yourself. Try to set it up, try and identify your variables, identify any rates as derivatives of those variables, see if you can write your equation, which we will have to find our equation here. Take the derivative and plug in the information that you laid out at the beginning of the problem into the derivative to find that missing rate. So try as much of this problem as you can. Then let's come back. We'll check our answers in just a minute. So hopefully you had enough time to try this problem out. The thing I'm going to start with is the variables, and in this case we're talking about X flash drive. So here X represents the number of flash drives. It tells me in this case that the production is increasing at a rate of 500 flash drives per week, but that word increasing makes me think we're talking about a derivative. So that's actually going to not be X, that's going to be dx over dt. So dx over dt is 500, and I know it's going to be positive because it's increasing being a positive rate of change. So dx over dt is 500. And it also tells me that the production is currently 2,000 flash drives. So my regular old x value is just 2,000. So x is equal to 2,000. dx over dt is equal to 500. This problem asks me to find the rate of increase in profit. So in other words, I want to find the rate of change of profit with respect to time. What is dp over dt? This is going to be what I'm solving for. If you want to, you could go ahead and find the profit function. It's not necessarily wrong to do so, although for this particular example, we don't need to find the exact value of the profit function at this particular moment. So here's everything that the problem gave me. I now need to write my equation that relates profit and x. Well, here I have profit is equal to revenue minus cost. I need to first of all find my profit function. So profit is revenue minus cost. So in this case, my revenue function is 10x minus 0.001x squared minus my cost function, 5,000 plus 2x. Remember to use parentheses here because we do want to take this minus sign and distribute that to both terms. You want to make sure we subtract both terms in our cost function. So I usually like to distribute that right away. I'm going to change that to a plus, and then I'll change the signs on the inside of those parentheses. And I'm just going to clean this up and combine any like terms that I can. So profit is equal to, let's see, negative 0.001x squared. 10x plus negative 2x, I should have plus 8x, and then plus negative 5,000. I'm just going to write that as minus 5,000. So here is my profit function. Now I could, if I wanted to, take my x value of 2,000 and plug that into my profit function to find out exactly what my current profit is. But that's not what I was asked to find. I want to keep in mind what it is that I'm looking for. I want to find the rate of increase in my profit. I want to know how is profit changing if I make these changes. So here's my equation that relates those two. I now need to take the derivative of that equation. So just like every other example that we've seen so far, I'm going to take the derivative with respect to time. So the derivative of p would be 1 times, again, profit is going to change as time moves forward, which means that profit is a function of time, which means I need to use implicit differentiation. The derivative of p with respect to time would be dp over dt is equal to, here I'm going to use my power rule, negative 0.002x, but again I'm taking the derivative with respect to time, so that means I need to multiply by the derivative of x with respect to time, so I multiply by dx over dt, plus the derivative of 8x should just leave me with a constant of 8. But again, here I took the derivative of x with respect to time t, which means I need to use my implicit differentiation. So even though this x disappears when I take its derivative, I'm still taking the derivative of that x, which means I need to use implicit differentiation. I need to multiply by dx over dt. Minus 5,000 here, when I take the derivative of that, I know that's just going to be 0, so I don't really need that part. You can include it if you want to, but in our problem, it's not going to make a big difference. So here is my derivative now. I've got dp over dt is equal to negative 0.002x times dx over dt plus 8 times dx over dt. And now I can take this information, that I laid out at the very beginning of my problem and plug it into my derivative. So in this case, we've got dp over dt is equal to negative 0.002 times x, and we said our x value is 2,000. So times 2,000 times dx over dt. Dx over dt, we said that was 500. Plus 8 times dx over dt. We've got another one, so that means we're also going to plug 500 in here. So here we just need to crunch some numbers. Let me grab my calculator. Negative 0.002 times 2,000 times 500. Here I have negative 2,000 plus 8 times 500. Here I should have 4,000. If I add those two together, I should end up with a positive 2,000. So that means that dp over dt is 2,000. I want to make sure I give a unit on this. Here, profit, dp, we're talking about our profit function. The unit on profit would be dollars per, what is our unit of time? In this case, t. If I go back up and look at my problem here, we said our unit of time was, we were measuring it in weeks. So it would be dollars per week. And if I want to talk about what this number means within the context of my problem, I would say that the profit will, in this case, increase. Since we ended up with a positive $2,000, it will increase by $2,000 per week if we make this change. So that is our last example for this section. These problems are difficult, they are challenging, so please make sure that you get your practice in with these problems. It is the best way to improve your skills with them and to improve your confidence with these problems, is just to get your practice in.